Welcome back, everyone. I hope everyone's having a nice day today. So let's go ahead and work out this integral. This is an trigonometric integral because we see this expression right here in our integrand. You have y squared minus a number, 49. So let's write down, when do we use trigonometric substitution? So if you have, let's say, the following form in your integral, say you have some a squared minus x squared. If you have that, then you're going to use the substitution x equals to a sine theta. Then another form when we use trigonometric substitution is if you have x squared minus some a squared, you're going to use the substitution x equals to a secant theta. And last form is if you have x squared plus a squared, or if you have a squared plus x squared. Any of this order, you're going to use the substitution x equals to a tangent theta. So if you see any of these forms, especially under the square root, you're going to use trigonometric substitution to evaluate the integral. So let's go ahead and do that. I see I have some y squared minus some number, 49. I can write that as 7 squared. It looks like we have this form right here under the square root. So I'm going to go ahead and come up with the following substitution. We will let y be equals to a. So in this case, a is actually 7. So you can write y squared minus 7 squared to match the form, because 49 can be written as 7 squared. So this is a, which is 7 secant of theta. Once we do that, now we can take the derivative of this substitution. Dy is equal to 7. The derivative of secant is secant theta, tangent theta, d theta. So now we can go back to our integral and make the substitution, translate everything in terms of the theta variable. So we have the integral of the square root of y squared. So y is 7 secant theta. That's 49 secant squared theta minus 49 times dy. Dy is 7 secant theta tangent theta d theta all over y. Y is 7 secant theta. Now, another thing you also want to make sure is that theta, when you make the substitution, you want to write this down, that theta is restricted from 0 to pi over 2, so that it's positive. Now let's go ahead and carry out the integration. So we have a lot of simplification to do. So inside the square root, I can factor out 49. So you get 49 times secant squared theta minus 1. And then here I can also cancel out the 7 and secant theta. So that leaves me with just a tangent theta d theta. Furthermore simplification. So this is an identity. Secant squared theta minus 1. Recall that tangent squared theta is actually secant squared theta minus 1. So I'm going to apply that identity here, replace this piece with that. So you'll have the integral, and square root of 49, that's 7. So you'll have 7 times the square root of tangent squared theta times tangent theta d theta. And then here I can freely cancel the square root of the square. That leaves me with a 7 times the integral of absolute value of tangent theta times tangent theta d theta. Now here, we're going to remember that tangent theta is positive for theta within the boundary 0 to pi over 2. So that's the restriction we came up with beginning of the substitution. So because of that, I can freely drop the absolute value around tangent. So this is 7 times tangent theta times tangent theta d theta. And then tangent theta times tangent theta, that gives me tangent squared theta. So this is 7 times the integral of tangent squared theta d theta. And now I can replace the tangent squared theta with this identity again, secant squared theta minus 1. So that gives me the following to integrate. I have 7 the integral of secant squared theta minus 1 d theta. And this, we know how to integrate. The integral of secant squared theta, that's going to be tangent theta. The integral of 1 respect to theta, that's simply theta plus c. Now we're finally completing the problem. So we have 7 tangent theta minus 7 theta plus c. Now you do not want to leave your answer in terms of theta. You want to leave it in terms of the original variable. So we go back to our substitution right here. We said that y is equal to 7 secant theta. So from there, we can actually retrieve the other trig functions. So for example, I can construct the right triangle. So we know y over 7 is equal to secant theta. So if you were to draw a right triangle based on this information, we can figure out the other trig ratio, such as tangent, because that's what we want in our problem. So let's suppose theta is here. It's an acute angle. Secant, the ratio for secant is hypotenuse over adjacent. So if this is your opposite length, this is the adjacent, and this is your hypotenuse. So this would be y, this would be 7, which means the opposite length has to be hypotenuse squared minus adjacent squared. So that's y squared minus 49. And now we can figure out what tangent theta is. So tangent is opposite over adjacent. This would give us 7 opposite. That's a square root of y squared minus 49 over adjacent 7 minus 7 times theta. Well, what is theta? Well, theta, we can get it from our original substitution by simply taking the inverse. So from here, if secant theta is y over 7, then to solve for theta, I can apply secant inverse. So theta would equal to secant inverse of y over 7. And that's what I'm going to sub in for theta. This is 7 times secant inverse of y over 7 plus c. And you can simplify your first term right here, cancel out the 7. Your final simplified answer would be the square root of y squared minus 49 minus 7 secant inverse of y over 7 plus c. So that will be our answer for this integral. All right, I hope you enjoyed. Have a lovely day.